limitations of Coulomb's law. Limitations of Coulomb's law. So there are some limitations here. So we'll study these limitations here, right? So this Coulomb's law is applied for static charges. So this is first limitation. Static charges means here Coulomb's law already statement is we have to consider two which are point charges which are static. Static means they are not movable and is separated by a distance r. Then Coulomb's law defined as F equal to Q1 Q2 by R square with some constant K. So what is the statement here? This Q1 Q2 are the charges which are in static. Static means they are stationary, they are not moving. So for moving charges, this Coulomb's law is not applicable. So that is the first limitation. So this is applied, can be applied only for static charges. Can be applied only for static charges. For moving charges means charges are moved, right? So this law is not applicable, right? Charges should be stationary. It should be stand at this point only. Then we have to take the distance r. Then only this Coulomb's law can be applied. That formula F equal to 1 by 4 pi epsilon Q1 Q2 by R square. This formula is applicable for Q1 Q2 are static. If the Q1 Q2 are moving, Q1 is moving like this means, or Q2 moving like this means, you can't apply this Coulomb's law. This formula is invalid. So that is the first limitation. So your Coulomb's law is applied only for static charges, right? Second limitation is the charges should not be separated by long distance. Long distance, the charges should not be separated. So what is long distance? If charge Q1 is there here, Q2 is there here, separated by distance r. This formula, because this process we know, because we have to take the which one distance between the two charges, that is the Coulomb's law by r square. No, if the distance is more, you can see this formula F is inversely proportional 1 by r square. If the distance is more means your force will be low. So when r is more means r square will be very more, right? Then at that condition your force will be less and it will be nearly equal to 0. So that's why the distance the two charges should not be very long, right? So that is one more limitation. So for the long distance values, your force will not exist here. So if there is no force, there is no Coulomb's law. So this is the second limitation. So for long distance, this which one Coulomb's law is invalid, right? And what is third one? Third one is distance between these two charges, that is r distance, should not be very small. Should not be very long is second limitation. Should not be very small is third limitation. Should not be very small means, suppose if the two charges are like this Q1 Q2, if the distance is like this, so distance between these two is very small. So what will happen when the distance is small? So actually the force which is there in this which is Coulomb's law, that is force of attraction or force of repulsion, is known as electrostatic force. Electrostatic force. Because this force is coming because of the charges, that is known as electrostatic. That is a definition, electrostatic force. Electro means charge, static means they are stationary. When the charges are stationary, that is charges you are studying, that is known as electrostatic topic. So you are getting electrostatic force. Electrostatic means charges are at rest. So you are getting a force. That force is known as electrostatic force. So a Coulomb's law formula 1 by 4 pi epsilon Q1 Q2 by r square formula, the force which you are getting is known as electrostatic force, right? So whenever the distance between these two charges is small, when the distance between two charges is small, what will happen here? Nuclear force will come into the picture. Nuclear force. Because in an atom, in an atom, proton and neutron will be there. This is already everyone knows. Proton and neutron. So this is electrons is revolving here. Protons and neutrons here. or because of this nuclear force, because nuclear force is much more high, so that there is a binding between this proton and neutron, right? So means your size of nucleus 10 power minus 15. 10 power minus 15 means 1 by 10 into 10 15 times, that is a very small value, and your this one nucleus is a very small one, no. So whenever this is a very small, in the small one only protons and neutrons are binding, so there you can see a very large nuclear force there. So whenever the distance between the charges is very small, means nuclear force will come. For the small one, for the small distance means again nucleus will be there and nuclear force will come, there is no electrostatic force. So distance between charges low means nuclear force will come there. So there is no electrostatic force, whichever the Coulomb law defined, that electrostatic force. So whenever the Q1, Q2 charges are like this, means like distance is r, then your Coulomb's law is electrostatic force is defined as 1 by 4 pi epsilon Q1, Q2 by r square. Right? When a distance is large, there is no electrostatic force. When distance is small also, nuclear force will come, because nuclear force of nuclear is very greater than electrostatic force. So whenever distance is small means nuclear size small, means here nuclear force will come here in this one. When a nuclear force is coming means there is no electrostatic force. So that is the third limitation. So this Coulomb's law cannot be applied when the distance is large and cannot be applied when the distance is very small. So this is one more limitation of the Coulomb's law. Okay, and when you compare this law and your Coulomb's law again depends on medium here. So you are telling that 1 by 4 epsilon, no, 1 by F equal to, one more limitation, 1 by 4 pi epsilon 0 Q1 Q2 by r square, no? Right? So this medium changes means this force value will change. So it depends on the medium. So Q1 Q2 here, so depends on the medium. What are the medium which is there, that is here. Another medium means your this epsilon value will change. So that's why this value 1 by 4 epsilon is not a universal value. Is not a universal value, only a constant value you are telling. The constant means depending on the medium. If you take air or free space or vacuum, this value is 9 in 10 power 9. If you take another medium means this value will change. If you take another medium means this value will change here. So this is not a universal value. It's not a universal value, just it is a constant value. That is one more limitation, because your this Coulomb's law again depends on the medium. If medium changes means this changing no. So that's why this is another limitation of which one, Coulomb's law, right? And when you compare this with Newton's law of gravity, because both formulas are same only. When you see this Coulomb's law, this formula is F equal to Q1 Q2 by r square. This is the formula. F equal to K Q1 Q2 by r square, formula for Coulomb's law. If you take the Newton's law of gravity, formula is this formula is there, no, G into m1 m2 by r square. So when you compare these two laws here, G is a universal constant value. G value will not change. It does not depend on the medium, whereas K value here depends on the medium. 1 by 4 epsilon, that epsilon value depends on the medium. So if the medium changes means this value is changing. So it is only a constant value, whereas if you got Gm1 m2 by r square, this G is a universal constant. So it does not depend on the medium. So that is one more limitation when compared to your Newton's law of gravitation. Same formula, here you are seeing, here charges are there, here masses are there, distance is r square only. Here you can say the universal value. So your Newton's law of gravitation does not depend on the medium, whereas your Coulomb's law depends on the medium. So this one more limitation when you compare this with your Newton's law of gravitation. And one more thing is, here charges are there, here Q1, Q2, here force of attraction is there, force of repulsion is there in Coulomb's law. Right? Charges are, if same charges you are taking here, force of repulsion will be there. If one positive and one negative charges if you take means there is a force of attraction. Right? Force of repulsion and force of attraction are there. then you can say net force equal to 0. F12 equal to F12 plus F21 equal to 0. This is the Coulomb's law which you are getting this one, because force of attraction and force of repulsion which is there, right? Whereas here there is here in Newton's law of gravitation only there is actually there is no repulsion force, only force of attraction will be there in when you take this mass m1 m2, right? There is no force of repulsion here, only force of attraction will be there between the masses. That is one more advantage of Newton's law of gravitation when compared to your Coulomb's law, right? And these are some of the limitations of Coulomb's law. Okay, thank you.